Okay, so at the end of this lecture, our goal is to have a good foundation and developed an understanding of orthographics and how they relate to three-dimensional objects or 3D forms, and how we can break down these 3D forms into their two-dimensional views. So before we jump necessarily directly into that, I'd like to take a moment to just kind of describe hand drawing techniques and skills and how they relate towards drafting. It used to be that hand drawing was the way that we did everything. So from the now you see it reading that you hopefully did for homework, you kind of saw the perspective of how back in the 60s, 70s, 80s, even as kind of recently as the 90s, people were focused towards hand drawing. In the 80s and 90s, and especially now, things kind of moved towards CAD skills. But hand drawing is still a very important skill set to have in drafting because we use it to sketch things out and explore different ideas without having to make that time commitment of putting them together on the computer. But the importance of neat and detailed technical drawings when it comes to hand drawings are really no longer that prevalent. So we're um, going to be approaching hand drawings in a much more kind of loose sketching technique. The area of industry that you're focusing on in hand drawing is important, and especially when it comes to the technical drawings of drafting, it's going to be very different when you're approaching from an industrial design perspective as opposed to an architecture perspective. And we're going to kind of go back and forth a little bit in our practices, particularly today. We're going to honestly look at things a little bit more from an ID side than from an architecture side, but we'll still see how the connection between the two is there. And as I mentioned, the hand drawing is really there to kind of get a quick idea, start to understand the spirit of a design or project, and then the computer is there to really flesh out all of those nitty-gritty details that would go in a set of plans in that legal construction document that's being put together. So with hand drawings, you can really start to express a quick idea of a layout or maybe an architectural style to a client or to a contractor without putting a lot of commitment forth in it, so that this way you can kind of show the quick layout to a client and they can either say what they like and don't like, so that way more details can be thought of before having to jump into the CAD work. Because with some CAD projects, that's a very long hours and hours and hours of commitment to it. And you don't want to put all that time and effort together just for it to not be liked and have to go back to the drawing board. So if you can sketch it out fast, that is going to be beneficial. Now, to start off with sketching, I always work with the pencil sight method, which is I look at where I want my pencil to end up for a line. I'm not looking at it as it goes across the page. I'm just kind of seeing where I want it to end up. That tends to help build up my lines a little bit better. One thing that you're going to have to start to let go of, if you haven't already, is to let go of the perfect straight line. So we kind of start off with very light lines, very loose lines. And I know if you are someone who has kind of more of a type A personality, it's going to be really hard to let go of that perfect line. One thing I'll intentionally do with my lines, and you see this over to the side, and you'll see it when I do my hand demos in a few minutes, is that I intentionally squiggle my lines because then I can say it was a stylistic choice. I was once very like, I wanted all my lines to be perfect, everything had to be measured to a T. Now I just tend to sketch things out a lot more loosely, and if I put squiggles in there on purpose, it's not that my line got messed up, it was that I intentionally did that. It was a stylistic choice. So that's something I'm going to try to encourage a little bit out of you guys, just so you can sketch a little faster and let go of that perfection in the sketches. The computer is where we can get perfect with things. Um, and then bounding boxes are really great to help define curves and other shapes very easily. So I'll almost always start any shape that I ever do. I'll start off with just a bounding box of its overall general dimensions and then kind of flesh it out from there. I like to think of it as if I had a big hunk of marble and I was then just chipping away to get my object out of that marble. Um, and I'll start all of my lines off really, really light and then darken everything as I go. So in the demos that I'll be doing for you guys today, I'm going to leave all of my guide work there and then just go over everything with a Sharpie just to kind of show you what the end results are going to look like. But I tend to think that the guide work can kind of add in this nice sketchy look to the hand drawing to help kind of solidify that it's something done by hand. But again, all of these techniques, everything that kind of goes with drawing by hand does just take time and practice. And one thing I've seen in classes is students get frustrated that their drawing isn't perfect the first time around, or even when they make a guide box for a circle and it doesn't come out the way mine does, they're like, oh, I'll never be good. And again, I'll have to reiterate that I've been doing this for a long time, and my lines were pretty poopy the first time around too. But with practice, years and years of practice, you can get better. There was a quote, I forgot exactly who had said it, but she said, it may have taken me only a few minutes to draw, but it took me a year to learn how to draw it in a few minutes. So just kind of everything comes with time. Now, in today's lecture, we're going to focus on orthographic style of view, which is a 2D style projection. But the other forms that we're going to look at next week and in the week upcoming for that, since we do have that one break this semester, spring 2022, we have 3D projections called axonometrics, which are isometrics and dimetrics and obliques. And then there's also perspective style, which we'll often look at as kind of a rendering or a still life imagery. So this often is kind of the hardest to work our way through and the one that requires the most practice because it's kind of that more traditional style art of making things realistic. Orthographics tend to be a little hard for students in just kind of taking that 3D form and breaking it into 2D views, but with practice comes understanding. Not perfection, because perfection is a social construct, but it comes understanding. So again, orthographic is a way of taking a 3-dimensional form and breaking it down into 2-dimensional planes or faces. It takes time to train your brain to kind of understand how an orthographic is made from an object and then how to read one, but through time you will get better at it. All objects have 3 dimensions to them. That's where 3D comes from, and those are width, depth, and height. So all objects have a width to it, a depth to it, and a height to it. And we then can break those down into 2D faces that then will give us 2 pieces of information, meaning each of those faces, though, is going to be missing one of those dimensions, and we'll look at some examples in a moment. But it's taking the object and projecting it onto kind of faces of a glass box to break it down into 2D faces. So again, another way we'll often refer to orthographics is we'll refer to it as a multiview drawing. And we're taking each of those principal faces and breaking it down onto a plane. So all objects have 6 faces to go along with those 3 dimensions. Those 3 dimensions, again, are width, height, and depth. The 6 faces would be then front, back, right, left, top, and bottom. And so we're taking a 3D object and we're essentially unfolding it into those 6 faces. Now, when it comes to architectural drawings, we do typically have to keep all of the faces because buildings are extremely complex. So I can't just kind of break it down into just 3 of those 6 principal views. I'll typically will have to keep the all 4 of the sides, but we'll see in some of our practices that when we break our 3-dimensional object into its 2-dimensional faces, some of them are going to give us repetitive information, and therefore we can kind of leave those out. So from an industrial design perspective, we can leave some of the views out. So here is a object drawn as just a 3D style. And so this is what's called an isometric drawing. And we have just the different projections of what the bottom, the top, the left, the right, the front, and the back look like over here. So again, this object has 3 dimensions: width, depth, and height, and it has 6 principal views or 6 sides to it. So if I'm looking at the front of the object, if I'm looking at it head on from the front, projecting it onto that 2D plane, I can understand width from the front and I can understand height. But what the front view is missing is depth. So I can see that there's a difference between these faces here and then this slot back here. So I can see that there's a difference, but in the front view, I can't see how far back that slot goes. Same thing with the fact that I can see that there's something different between up here and then this face back here. So that's being projected on the front. However, I can't see how far back it is. So the front view can tell us the width and can tell us the height, but it's missing information related to depth. So think too, if we're looking at then, just to fast forward a bit, a set of plans, and I'm looking at the front of a building. In a set of plans, I'd be able to see, that there's a porch up here and then the house, but the front view of that plan, or that elevation, wouldn't be able to tell us how far back the house is and how far forward the porch comes. Now with a top view, we now get information related to depth and we have information related to width, but the top view is missing related information to height. Since these are 2D projections, they only give us 2 of those 3 dimensions. So in the top view, I can see that there's a difference between this face up here, and I can see that there's this face down here, but I can't see how far down this particular face is. And then the same thing with our side view. We get information about depth and we forget information about height, but we're missing anything related to width. So all of these views are missing at least one piece of information, which is why we need multiple views in order to fully describe the 3-dimensional object. Some of these views are giving us repetitive pieces of information. So if we look at like the left side and the right side, they're giving us pretty much the same thing. It's just a mirrored copy. And so that's why often in industrial design, we'll only draw 3. We'll draw like the front, top, and right. We'll draw the front, top, and left, but we'll leave out the rear view and the bottom view or one of the sides. Just because if it's giving us the same information, we don't need to overcomplicate the drawing. But again, in architecture, our front and our back of our house are going to be probably very different, that we want to make sure we're just putting all of the principal views on our set of plans. There's also a couple of concepts too that we can see here related to things like curves or objects that are kind of inside the 3D form. So we can see here in the top view, looking at it as a 3D object, there is this curve to the shape. However, if I'm looking at it here in the top view, I can't really see that it's curved. And that's because, again, we are only seeing 2 dimensions. And so I can't see this curve down related to height because height doesn't exist in this top view projection. So curved objects tend to just only appear as kind of showing where their quadrants are, or their edges, for lack of a better term. I know circles don't have edges, but for the fact that my pea brain wouldn't know what exactly to call it, this would be kind of the quadrant of it, one of the four corners of the circle, as we can see there, but we can't see that it's a curve. That's why in industrial design, we would define it with what's called a center line, which is this long, short, long line to help understand that it's curved. In architecture, that line takes on a different meaning, and we'll go over that in the architectural symbols and standards lecture, so don't fret too much or scramble to write everything down in your notebook. The other concept that we can see here are related to these short dashes, which are called hidden lines. And hidden lines are meant in both industrial design and in architecture to show features that are present but just aren't visible in a particular view. So if I'm looking at this object from above, from the top view, this hole that's blasted through this back face isn't visible in the top. If this was made out of a solid piece of wood, I can't see that hole going all the way through, which doesn't mean that it's not there. It just means I can't see it in the top view, which is why it's projected with these hidden lines for the quadrants of it. Same thing then in the side view, is if I'm looking directly at the side, I can't see the slot that's back here through the middle. And that's why the back edge of it is this hidden line to show that that's how far back that slot goes. And the same thing then with the hole that's going through that back face. Hidden lines aren't necessarily always present in every single object. It just depends on the object being described and the features that it includes. And same thing with center lines. If an object has a curve, then a center line would exist, but if an object doesn't have curves to it, then hidden lines wouldn't be necessary. This isn't something I want you to stress too much over as well, but again, this is just kind of related more towards industrial design. So one thing to keep in mind is in America, we use something called third angle projection, in which we have our front view with our top view aligned above that, and then usually the right side. In first angle projection, which a lot of the rest of the world uses, they use the front view with a top view above it and then a side view projected over here. So they'll use the left side where we typically use the right side. But we just have our different faces of our object projected onto the different planes. So that way it's two-dimensional. Now, another thing we'll look at today, but again, I don't want you to freak too much over because it is much more industrial design related than architecture, is things related to spacing our views and view alignment. So the two reasons why we want to focus heavily on these is it does make drawing easier. View alignment is still something very important in architectural drawings if we have more than one view on a sheet of paper. So if we have the front face of our building on the same sheet of paper that our floor plan is, we want to align those views with each other. And what I mean by that is, you see here for this staircase, that this edge is lined up with this edge of the front face. And that's because it's helping show the relationship between the front of the object and the top of the object. And the same thing then with the front and the side, is that these are lined up. So this way, every one of these features is just kind of in tune with each other. And then it's also going to make it so I have to take less measurements for the building itself. So if I had a set of plans and I was going to put the front of the building and the right side of the building on the same sheet of paper, I'd want it so that the bottom, the kind of ground for the front, is lined up with the ground for the side. So that way I can see how these views are relating to each other in the set of plans. Something I'll look at in my hand drawing practices today, but for architecture this doesn't really apply, is something called the miter line. So for those of you who are a little familiar with woodworking, a miter joint is a joint done at 45 degrees, and a miter line is done at 45 degrees. So we do our miter line 45 degrees in this front view to just kind of help project our side view over, and that would help keep even spacing between here and here. But again, that's not the most important concept, especially in architectural drawings. For industrial design drawings, it is an important concept to look at. So what I'm going to do now is move over in a moment to my hand drawing camera, and I'm going to work out these two objects as orthographics. I am not going to be doing it very technically with my T-square and using all of these specific measurements and rulers. I'm going to be sketching everything out using just some graph paper, because again, my main focus with this is to make sure you guys have an understanding of how the 2D faces come out of the three-dimensional object, not necessarily using all of the equipment and perfection of measuring, because I'm hopeful by now in college you guys know how to read a ruler. But I guess I'll see in a bit for that. So I'm going to start off with just doing this one as a hand drawing, kind of just sketching out what its faces are going to look like, and then I'll do one of this one. You, as a student, do not have to do these two objects. This is more just for you to kind of see and understand, but if you wanted to follow along with them or practice them yourself, or even then email me for other shapes to look at, to practice with, I've got loads of these little drawing shapes. So, and it's a great way to practice, is just to take these random forms, try to build them out. But let me switch over to my hand drawing camera and then walk myself over there. What a fun little narration we have going. Okay, so for these, please tell me my camera's still on. Good. Sometimes it disconnects. So for these, like I said, all I'm going to be using is a piece of graph paper. If you wanted to tape it down and use like a T-square and everything along with it, feel free. If you wanted to keep your lines nice and straight on the graph paper and use like a ruler to just keep everything nice and neat, again, you absolutely could. I'm going to just freehand sketch things on the graph paper for two reasons. One, I trust myself to do it well, and two, because sketching is much more of just being able to loosely understand things than to make every single little line perfect. So I've got in the corner there my 3D object, and as I mentioned briefly at the beginning of this presentation, that when I do hand drawings or when I'm really drawing, even on the computer I'll sometimes do it, is I like to just try to make an overall bounding box and then just kind of carve my shape out of it. But I'm still going to follow the projection style, in which I'm going to start with just what does my front view look like here, my top view, and my side view. So I'm again not going to use those measurements to the side, but if you wanted to, you could. And what I'll do is on As You Learn, I'll link a video from last semester in which I did use all of the tools and the measurements, so you can see how it would apply there as well. But I'm just going to start by making an overall box. Another good thing to keep in mind with your hand drawings is whenever I'm moving my pencil, you're going to notice that I move my whole arm. So I'm not just moving my wrist kind of back and forth, because that's going to make my lines wonky and curved. So I'm always going to just move my entire arm across the page. And a lot of times too, what you'll see me do is, without putting my pencil down on paper, I'll kind of just go back and forth to trace out an object. And then once I know that that's where I want a line to be, then I'm going to put my pencil down to the paper. So I'm just going to kind of generalize that I've got a width for that front view of about that long. And then I've got a height of about that tall. Maybe that's a little too tall and I can just go and change it later. And so I'm just going to create a big old box for my object, and then I can start carving out what I want the front of it to look like. So this is my front. It has, to reference those measurements, it has an overall width of 6 and an overall height of 4. Now it has this little slant face here, which I unfortunately can't use the graph lines for because it doesn't follow the parallel and perpendicular lines on this graph. So instead, what I've got to do is figure out how far over on this top face that slant starts and how far up is where that end point of it is. So again, I'm just going to generalize and just make like a little mark saying it's that far up and it's that far over. And now that I know where it starts and where it ends, I can take this line that isn't parallel or perpendicular and I can connect the dots. So what I'm doing again is just kind of moving my pencil across where I want it to hit without putting my pencil down on the paper first. So I'm just kind of moving it across, and then I'm doing several pieces of line. Let me make sure I'm on the camera. Several lines just to kind of flesh out that line a little bit more. So again, I'm going to leave my guide work on the page just so you can understand how I got to my end result from here. But with Sharpie, here is my front of my object. That got real wonky there. So with the front view, I can understand anything related to width and I can understand anything related to height, but I can't see anything related to depth. So I don't know how far back any of this object goes. For the top view, I want to make sure that I am aligning it or orienting it right above the front. So one way that makes that easier too is just to project guidelines straight up from here. So from each of these features, I'm just going to project a guideline straight up. And especially since I didn't use any measurements to do this, it's going to save me the annoyance of trying to measure out how far over this is and how far over that is, because I just have it projected directly above. So I'm just going to pick somewhere to start. And so this essentially is the same as that top left corner of my object. And then I'm just going to say how far back I want it to go. And in this case, this little slide shape is just projected straight or extruded straight out. And so my top of my object is going to look just like this. Now, in this scenario too, our guidelines for projecting really helps because this line, if I took a ruler to measure it, this line right here from this point to this point is going to read as shorter than this entire slanted line. And that's because objects that are slanted are going to appear as foreshortened in an orthographic view. So we have this slanting downward. This also is technically slanting downward, but if I'm looking at it directly from the top, because keep in mind the top isn't showing me anything related to height, I can't see how far down it slants when I'm looking at the top view. So it's going to appear foreshortened. The way I'll often describe it to students, which I guess you too, you're technically students too, is that think about if you were looking at somebody's backyard and they've got a big in-ground swimming pool with a slide going into it. You're not going to see in Google Maps you're not going to see that slide down into the pool. You're not going to see how it is kind of curved downward. But if you looked at it then directly from the side, when you're standing in their yard, you would be able to see it go down. So in the top view, we're unable to see how far down it's going because the top view doesn't tell us height. Top view tells us width and depth, but nothing related to height. Now, our side view, again, we're going to just orient it so that way it's aligned with the front view. And we'll use, in this example, the miter line technique to bring it in there. So the miter line technique is drawn at 45 degrees, and it's taken from the front view. Where you want to draw it is from where your topmost and rightmost lines of the front view meet. So in a lot of cases, it's directly on the object. In this case, it would be right here because it's where the topmost and rightmost lines meet. That isn't directly on my object, but that's still where I would do my miter line. So this again would also be somewhere where, or a scenario where having like my set square and my t-square would be ideal to just project that out. But since I'm using a piece of graph paper, all I'm going to do is just draw a line that goes through the diagonals of these boxes, because that's also 45 degrees since these are perfect squares on a graph paper. And I'm just going to go 45 degrees out, and then I'm going to project these edges over to meet that 45-degree line. So what this is going to allow me to do is it's going to allow me to take the depth measurement I have here and just project it straight down without technically having to take any measurement. Now, could I have said, okay, well, I made it 1, 2, 3, 4, 5 boxes and then counted out 5 boxes? Absolutely. But in a scenario where maybe I had a bit more complicated of an object, this is going to help me then just transfer a lot of those measurements and a lot of those features directly over. So same thing then here is I'm going to just use guidelines to just project these features straight over. And then for my side, I'm able to see depth and I'm able to see height. But I'm not able to see anything related to width in the side. So the side of the object, again, I can understand that there's a difference between this face and this, but I can't see the slope from the side. So again, it's appearing as a foreshortened surface. So this is that first object, or that object right in the corner, actually, broken down into its 2D faces. I don't need to draw what the left side would look like because it's going to give me all of the same information, but actually it's going to then have like this face. If I'm looking at the left, I can't see it, so then it would be a hidden line and it would just kind of make things a little bit more complicated. So I don't need to draw things like the bottom, the left, or the back because it's going to give me a lot of the information I already have. So in objects like this and a lot of industrial design objects, we only have to draw the 3 views. Okay, now let me change the picture. I guess move it into place. And I'll do this guy. Again, I'm just going to sketch it out. I'm not going to measure anything. I'm not going to worry about my lines being perfect. I'm sorry if that is irking some of you, but it's just how I roll when I do hand drawing. And so again, I'm going to just draw out an overall bounding box for what the front of this object is going to look like. And I'm just going to start it in the lower left corner. And what I've heard in the past from some students is they're like, even your line where you're not trying is still way straighter than mine would be. And one, again, it's because I've just done it longer than you have. But the other thing is I'm using that pencil sight method. So I'm looking at where I want my pencil to end up. When I'm drawing it, instead of focusing on my pencil down here and just following it with my eye the entire time, I'm looking at this point pretty much the entire time as I go for it. And then it tends just to kind of end up a little bit nicer, but it's also just time and practice. Time and practice. So I'm just going to start off with an overall bounding box, and then it'll just flesh out some of the different slots and features. So about this far over, we've got that little slot that goes down, and it's about this wide, give or take, and then comes back up. And I could go through and erase my guideline there, but I'm going to keep it there for now. So for my top view, a lot of times too, when I'm projecting these guidelines, I don't draw them all the way up. I just kind of eyeball it to where I want it to be, and then I'll start projecting the guide, because then it will be just a lot of line work to have to erase. So I'm just giving myself a lot less work to erase is all. And I'm just guesstimating a good depth. So it has a depth of 3, and I'm just kind of saying, well, if that was 6, that seems about 3. But again, I'm not aiming for perfection in this sketch. And then I've got to add in these features related to this slot here. Now, in this one, in the front view, I couldn't see anything related to it. So we're actually going to have to go back and revisit in the front view to add in descriptors for that little piece. But it's a little bit back and about that wide. And I'll project some lines over for it. And then if I'm looking at it directly in the top, and for here, I will go through and erase. I like to say things and then do the exact opposite. Isn't that fun? Isn't that what you're always looking for in an instructor? Someone who tells you to do something and then does the opposite. But just to kind of show how this is almost like 2 little rivers that are kind of meeting to each other, but then there's still that back face there. So in my side view, if I wanted to do the miter line technique, I would be projecting it this time right from the corner of the object where the 2 of these are meeting. And I would just project my 45-degree line. I could take a ruler and just, whoops, I hit my lamp there. And just put it across all the diagonals. I'm actually gonna not even use a miter line, so I'm just going to show you how, like, if I just sketch this out over to the side, I'm still just going to want to make sure that I'm aligning all of these features. So if I've got my side here, what you want to make sure you're doing when you are like eyeballing a side view compared to using the miter line is that you are using the exact same depth here. And one tool you can have to do that, which, where did I just put it? Because I had it in my hands earlier and I was playing with it. One moment, I'm going to have to de-mic to go find it. Whoops. How do I get this microphone off? Maybe not. Okay. Oh, jeez. So, my long walk for a short drink of water there is just to show you this tool here. So this is called a divider. It's pretty much a compass, but it just has two really sharp pointy ends instead of just the one. And what I can do is use it to measure how much that is and then transfer it over here, which again, I think I eyeballed that right on the money, but yeah, again, practice, and you can just eyeball measurements quite a bit. Imagine what I could do with my life in time if I wasn't able to perfectly eyeball inches. But I'm just gonna flesh out my side view. So I'm just taking whatever measurement I had here, using the same one here, and then making sure that these are lined up with each other. This feature here, projected over, and then project these measurements over. So again, I could just say, well, it's 5 boxes, or I could use like a divider to measure it over. Or I could, if I didn't have one of these on hand too, I could use a ruler to just say, well, that's 1/2 of an inch, and then measure over 1/2 of an inch and project it down. And again, if you wanted to look at the video from last semester where I have all of those technical measurements, you could see that happening. So here's a lot of the features projected into the side view. However, we're not done yet because some of the features are hidden when we're looking at the side as well as when we're looking at the front. So if I'm looking at the front of the object and it's just a solid wood block in front of me, what I'm seeing is this. So if I'm looking at the front, all I see is this, but I still have that slot back here that's running through the object, but I can't see anything related to the height of that slot in the front view because it's blocked out by this portion of the face. So what I'll need to have there is a hidden line that runs right here to help describe that there's something going on behind this face that we can't particularly see in this view. So a hidden line, like I mentioned, is those series of even dashes. What you can do, and since I mentioned it previously, is you can get one of these things, which is called a eraser shield. And what an eraser shield does is we can put like these dots. I know the glare on the camera is really annoying, but I can put this dotted part over it and erase, and then it'll make like a series of dashes for us. But since we're doing a lot of this as rough sketch, I'm just going to add them in manually. You always want to make sure too, and this is for industrial design and architecture, that when you're doing hidden lines, you're always starting and ending with the line on the object. Now for my top view, in this particular instance, there is nothing hidden about the top. So if I'm looking at this object directly from above, everything on it is visible. Now in my side view, we have a hidden line going through right here, and then a small one also happening over here, because that line is defining this slot going all the way through up here. Excuse me, my arm was just entirely in the way. Going all the way through up here, but when I'm looking at it in the side, I can't see it. I can only see just that portion of it. This line here would still remain because this back face goes all the way through the object. The reason why there isn't a line up here on this one is because this slot goes all the way through. this one goes through and then hits right there. If this went all the way through on both ends, then that would be open on that side as well. And so that would be this object broken down as a 2D orthographic. And as I mentioned, it is something that just takes a lot of time and a lot of practice to go with it. So I do have more of these kind of generic textbook shapes for you if you wanted to kind of practice through a lot of them. I also have a lot of recorded videos going through the textbook shapes. So if you wanted to kind of check your work, feel free to email me and I'd be happy to send them along to you for you to practice with. And then, whoops, hold on, let me switch back to the display. There we go. So the way all of this relates to architecture is through the same concepts, but through a house. So I mentioned earlier, if I've got a porch and my house itself, if I have a front view, and what we typically call these projections of a building, the elevations, I can see that there's this porch and then the house itself, but I can't see how far forward the porch is. I can see there's a difference between this side area of the house and then the main area, but I can't see how far back that goes. That's then where these left and right elevations come into play to help see how far out the house is projected. And again, I can then see that this is different from here, but I can't see how far back this main portion of the building is from this little push out. And when it comes to our floor plans or our roof plan and our framing plan, those all then come from the top view and the bottom view of the building. We can get those from those projections. So it's the same 2D projection concept, but it's dealing with a different object compared to some smaller things that we might be doing with industrial design. So a plan view of a building is an orthographic cut through the building itself. Typically, this cut for a floor plan is about 4 feet above where, above the floor line or the ground line of the building. Because at 4 feet, you're able to cut through windows and openings for doors and get those details in the floor plan view. If you make that cut too high, you're going to lose some of the windows, and we just don't want that. So we're able to see the solids, which would be the walls, and then the voids, which is just the open space of the room. One thing that really throws a lot of students off when making plans is that they do not consider that a wall has thickness to it. So keep in mind that walls are made out of materials. They're made out of pieces of dimensional lumber, gypsum wallboard, siding, all of that, and all of that has a thickness to it. So a wall is never going to appear as just one single line in a plan. There's going to be an outside and an inside of every single wall, and they're typically going to be around 6 inches or 8 inches thick within your particular drawing. Another thing to consider with plans, and we'll look at this in a bit more detail later on, is that we have different line weights and line types. So that's going to be differences between thicknesses of lines. Some lines are going to be heavier to really put emphasis towards them and to also show that this is right where this fresh cut of the plan is being made, versus kind of areas where we're going to have lighter lines to help define maybe things like furniture plans or where windows are going to be placed. A section view is a cut through the building again, but this time it's vertically. So a floor plan is cut horizontally, a section's cut vertically, and it helps show the volume of a building and also a lot of the construction details. So the section is important for understanding how the foundation is set into the ground, how the floor is connected to the foundation, how the walls are connected to the floor, and how the walls are connected then to the roof. So we can see all of those important construction details, and we're cutting the object open, we still have thickness to our material. So again, our floor is not going to appear as just one single line in there. There's going to be a bottom of the floor and there's going to be a top of the floor because it's going to be made out of different materials to it. The section as well is important to help ground the drawing, and what we mean by that is to show how the building is situated in the earth itself. So to understand how the foundation is placed in there and how just the building relates to the site that it's being placed on. And then elevation views translate best to those orthographic practices that I just showed and the orthographics that you are going to practice sketching out momentarily in class. So elevations are depictions of the outside of the building from the four principal views. We are typically going to define them as like the north elevation, south, east, and west. You can have more than 4 elevations if you have a building that has a particular amount of sides and maybe it's a little bit more complicated, but often we just break it down into those 4 principal elevations. And we're still grounding the drawing, so we'll have a very thick line at the edge of the elevation that defines this is where the dirt is, the earth is, and then we're building up height and we're building up width, or we're building up height and we're building up depth. And with that, I believe we are all good for elevation or for orthographics. So again, it does take a lot of time to practice our orthographics. What we're going to do in class, at least in this current semester, spring 2022, and I say that because I'm hoping to use these videos for multiple semesters, but maybe change up some projects, is I'm going to give each of you a little bathtub toy for you to sketch out, very loosely sketch what it's going to look like from those 6 principal elevations. What does it look like from the top, from the left, right, front, and back? And just to kind of help break it down into those 2D projections. And then as we progress through the course, we're going to then see how that relates to different buildings. Some things too along with the computer. So particularly with SketchUp and with Revit, which are 3D modeling software, we will create a 3D model of our building, and then it's going to automatically break it down into the 2D projections of what the floor plan would be, what the elevations would look like. Same thing then with CAD work. So from an industrial design perspective, you would use a software like Inventor or Rhino, SolidWorks, Fusion 360. You could use any of those softwares where you would make a 3D model of your object, and then it would make the orthographic for you automatically as well. So there have been advancements in the computer portion of things where you don't have to worry and focus as heavily on that projection because it can do a lot of it for you, but it is still a good idea to have that good understanding of how everything comes together. So with that, if you guys have any questions or want more to practice with, please make sure to reach out to me via